Okay, good morning. Welcome to
MathyMath140.
Yesterday, we did a project on some amazing art from Anne-Marie Eisen. And she sent me this link showing that somebody had done it on a computer, so we actually didn't have to build it ourselves. And so you can move these sliders. So this is multiplication by m. That's that slider, mod n, and it does all the pictures for you. So I wanted you to play around with this and just see what you had to say.
Well, I'm going to look at the 150 one. I think it was 0 mod 150.
Multiplication by 0. Actually, that's interesting. Go back to that. What does that tell you? Multiplication by 0 mod 150.
Well, it looks like 0 times anything is 0.
Yeah, so
and nothing intersects.
Nothing intersects except where do they all intersect?
At 0.
Which is where? On the picture. Yeah, right there.
Right
So
there.
actually we had put 0 down here, but they're putting it over there. So that's kind of neat. We learned something there.
And then here's the 2. That was the Mandelbrot that she made.
Uh-huh.
What happens if we take it up? It gets like more detailed almost. Like that hazy area looks like this is where a bunch of points connect. Where's that circle? Sometimes they look like jumbled lines. That's everything.
Yeah.
Interesting.
Yeah, what do you think's going on here?
It's like, yeah, that's another Mandelbrot.
Yeah.
You're taking the 120 here times every number up to 500. Mod 500.
Yep.
And you get this crazy shape.
Yeah, what are some of the things you notice about this shape?
Well, it's symmetrical. Like there are these areas where it looks like a lot intersect. And there's a center area where not very many are.
That's true. What are some mathematical questions you think you could ask about any of these shapes?
Well, how many ways of symmetry do they all have?
Yeah, and it's actually an interesting question to even ask what the symmetry means here.
Like here, it looks like you can fold it
Careful.
over.
Oh gosh, be careful with that on the screen, please.
That line right there.
So you think it's symmetric?
Symmetric if you fold the top down to the bottom.
Top down to the bottom. Okay, interesting. Yeah.
But others, like, maybe if I make one like here.
Okay.
It seems like this one could have 5-fold symmetry.
Whoa, 5?
Because there's 5 lines intersecting that central point at the center. There's also 10 of these little petal things.
Yeah.
Or 10 of these points, so it could have 5-fold symmetry.
Yeah, it might even have more, actually, because for example, it doesn't look like it has a horizontal line here in the middle, but it still looks like you can fold it over that horizontal line.
Yeah.
But it's, yeah, that's great.
It's interesting. Interesting program.
Yeah.
Like when you make this down, it starts at simple and then seems to get more and more complicated. And then this one's the most complicated of all. But at 3 it's just a line.
Yeah. Multiplying by 11 mod 3.
All of them are either lines, 2 lines. Yeah. Looks like they're like lines and 2 lines.
What do you mean 2 lines?
Like that.
Oh, I see. Okay.
And then it gets more and more complicated as you bring that thing up. This one looks like it has a lot of symmetry.
Yeah. Yeah, it's amazing. why some certain ones have certain symmetry and why other ones don't have that symmetry.
Hmm.
What do you think?
Pretty interesting.
Is this something you'd like to try to study a bit more?
Maybe.
Okay, cool. Thanks.